Okay, today we'll learn how to unsupervised satellite image into different clusters using means clustering algorithm. So for this unsupervised image classification of satellite image, we need two packages which I have already installed in my laptop, and just I have to call the packages. The first package is raster for reading and analyzing raster data, and the second package is cluster for clustering the data. Now after calling all both of these packages, now I have to go for importing the raster bands, and here I can import the raster band by giving a name. And for the first band 2 of Landsat 8, I am using name of blue because it represents blue band. And after giving a name, I have to provide assignment symbol, and then have to write the function for importing our raster data, and the function is raster. So if I click on this raster function, then I have to put the address bar of that uh, raster band within this double inverted comma. So I have already created this code, and I am just copying the path from here so that the video take very less time for performing all the steps. So after importing this file path I have already explained in a previous video, now I am just importing all the band locations so that we can reduce the time for this video, and just pasting it here. So now we have to run all these codes to import all the bands into this R environment so that we can perform any task. So the next task is to import a shapefile uh, for our area of interest, so that the unsupervised cluster does not perform on the whole satellite image, which may take uh, long time. So for reducing the time of this video, I'm just taking a part of the whole satellite image for classifying the image into different clusters. And for that also I have to uh, assign a name, and then after giving the assignment symbol, I have to put this shapefile function, because shapefile function can read any vector file. So I'm also similarly copying this address bar from one of my prepared code, just pasting it here. And if I run this line of code, then it will import the study area shapefile into our environment. And after that, the next task is to crop this satellite bands for my specific study area which I have incorporated. So similarly here I have to put a name. Here I am giving blue crop, as I am cropping the image for cropping the blue band for my study area, and the function that I have to use is crop for cropping the image. Here I have to put the name of the raster band first, and then after giving a comma I have to put the shapefile name I have given. So in this way we can crop all the bands. I'm just copying this code from the same script, saving time. So after writing this line of codes for cropping all the bands for our study area, now we can write this code, run this code for getting the cropped image for our interest areas. So now I have to create a composite image from all these crop bands, and for that I have to assign a name similarly, and the function that will be used is stack. Here I have to put all the crop bands name so that composite image is shared from all the bands that I have cropped. So after putting all the names of the crop band, now if we run this line of code, then it will make a single composite band from all these crop bands. So after this composite band, preparation of the composite band, now our task is to convert this composite band pixel values into numeric values. And the function will be get values, and within the bracket I have to put the raster data that we want to convert into numeric values. So now if we run this line of code, it will convert pixel value into numeric values. And after that we can check the structure of this converted data. It will show the actual structure of the data. Sensitive, I have to give the right name. And now the next task is to create a seed value, because k-means clustering is totally dependent on creation of random centers or random cluster centers. So I have to put a seed name, and here I am using 99 seeds. After creating the seed value or preparing the seed value, now the next task is to classify the image into different clusters. And here I am using a name for the model, that is KNR, and the function for k nearest neighbor function is sorry, the name of the model is and for k-means clustering the function is k-means. So here I am instructing that the NA value, that is null value, should be avoided from this data. I have already created during the conversion from pixel value to numeric value. Next we have to assign, or we have to mention the number of clusters. The number of clusters will be, I'm giving it as 10. And next I have to assign maximum iteration. Maximum iteration here I am giving 500. And next I have to give in start value, I'm giving it 5. And at last I have to assign, or I have to instruct which algorithm will be used. Here I am using void algorithm. Classify clusters. It will take some time to classify it into different clusters, and uh, within this time I'm just writing the next code. That is, if we want to check the structure of the model, then we can use this str function of next. Next for After classifying the image into cropped image into different clusters, now we have to create a empty raster layer for the whole for the specified area, and that can be performed from here. We are using one band of this composite image. Here we can take any of the bands for creating an empty image or random raster image. And after creating this raster random raster image, then we have to transfer these clustered values that we have already prepared using this k-mean cluster model. We have to transfer this value into a raster data layer. So that can be performed by uh, values knr, that means which we have prepared earlier as a empty raster data. Then we have to assign the symbol, and next we have to put the cluster value layer, k-mean cluster value. Now we can see the structure of this knr that we have prepared, and as this line of code is finished its work, now we can check the structure of this data. The function will be str instead of srt. You can create a vector file raster layer, then we are transferring the raster values into the raster, then we are checking actually the structure of this knr. So after that we have to assign some color for all the cluster that we have prepared, and I have already given the color name here. So we can just pasting this line of code for assigning 10 colors for 10 cluster. After assigning this color, now you can plot this result, unsupervised image classification result for plotting section our environment. We are just plotted here the result, ultimate result. So we can found that the cluster starts from 1 to 10, and the whole area, the area of our interest is divided into 10 clusters. So in this way we can classify a satellite image into different number of clusters as per our requirement.